Section 1.6 allows us to review some of the rules for differentiation that we've already learned. So let's look at the power rule. So I have written here the power rule in what I like to call math-ese. So there's the math language format of it. So let's give ourselves a couple of examples. And remember, the notation is very important. So f of x equals, let's say it equals x to the 8. Then f prime of x will equal 8x to the 7. That's your basic power rule. Now, what if my initial function doesn't conform to what I would like to the power rule in its current format? What do? So let's go back, and I'm going to erase this. Okay, and let's say that our function instead looks like this. How about 1 over radical x? All right, so my first step is not going to be to take the derivative, but to rewrite my original function as x, since it was in the denominator, I'm going to bring it up to the top, negative 1/2. So therefore my derivative would now be, and notice I've used the prime notation, negative 1/2 x to the negative, so you're going to be at negative 1/2 and go more negative by another 1, so it'll be negative 3/2. So that's a little quick review of the power rule, and on the next slide we'll do the next rule in the order that's on your note sheet. The second point in the notes is the constant multiple rule. And we've practiced this also, but let's use our other notation, the Leibniz notation. So if I instead have f of x, excuse me, let's go back. I'm going to use the Leibniz. I should actually do it. Okay, so if we say take the derivative with respect to x of the function 6x squared, that derivative would be 12x. All right, that's the notation. If I say take the derivative with respect to x of, how about 8x to the pi, that derivative is 8 pi times x to the pi minus 1. Think about that for a minute. All right, that's our constant multiple rule, which you've already practiced with the power rule. So the next one's going to be the sum rule. Using the sum rule, this just tells us if you want to take the derivative of a sum, so a function plus a function, you can do it by taking the derivative of each piece of the sum. So let's go back to function notation. So if I say that my g of x equals 7x to the 5th plus 4x to the 3rd, then to take the derivative, I'm just going to move from the left to the right using the power rule each time. So 5 times 7 would be 35x to the 4th plus, and now go to the next function, if you will, and use the power rule again. 3 times 4 is 12x to the 2nd, and that would be your final answer. So those past 3 little items we'll review. So let's now go to the new rule, which is the generalized power rule, also known as a chain rule. The chain rule is something you want to do very carefully because it's going to be with you for the rest of the calculus course, and also it's what people tend to make little errors with, and those little errors will compound themselves if you are not careful. Okay, the easiest way to understand the general power rule is to first look at the power rule. So what if I said f of x equals x to the 6th? So you would tell me that f prime of x equals 6x to the 5th, and you would be good. So what I'm seeing right here is that my x is raised to a power. the way the general power rule shows up is the following. So let's say that we have a function, but instead of raising x to a power, we raise a function to a power. So let's say our function is 7x squared plus 2. Okay, so we're going to take the derivative. Take your derivative, use the power rule, bring down the 6, treat this as if it was an x by just writing it down, just like I would have written down the x in the previous example. Now the power rule tells us to raise that to the 5th. Then the best notation to use at this point is to tell yourself you're going to take the derivative with respect to x of what was inside those parentheses. Okay, so I'm not done yet. So let's go one more step now. I'm writing down exactly what I see because this part has already been completed. Now, what's the derivative with respect to x of 7x squared plus 2? And you should be saying that it is 14x. All right, so you see how the power rule kicked in? So how would you write this in your final form? So you could bring the 14x up in front and multiply it through if you want to, but I'm fine with it staying that way. If you wanted to multiply the 6 in, you make that 14x a bigger number. So I would say, oh, and I'm so sorry, I needed to have my power here. I hadn't written that in. So I would say leave it be. If you didn't leave it be, it would look like the following. So 6 times 14, that's 24. 6 times 1 is 6, plus 1 is 8. So that'd be 84x. And then that whole thing is multiplied by 7x squared plus 2. And remember, we had it to the 5th power. Now, you cannot multiply that 84x inside because you've got the 5th power. So you're just going to leave it be like that. But I would say that your best answer is the step above. Don't multiply where you do not have to. Okay, let's do another example of the power rule on the next slide. Okay, given this function, let's use the power rule and the chain rule to find the first derivative. Okay, our first step is to put it in the form that conforms to the rules that we know. So I'm going to take this out of the radical and put it to the 1/2 power instead. Okay, then you're going to start taking your power rule, bring the 1/2 down, and you have 2x to the 5th plus 7x, and now that's raised to the negative 1/2. Then tell yourself to take the derivative of what's in the parentheses, because what's in the parentheses is not just a plain old x, it's a function. So doing that and taking it one more step, okay, so I have 1/2 2x to the 5th plus 7x to the negative 1/2. Then take the derivative of what's inside, and I'm going to stress, the safest way to do this is to tell yourself you're going to do it in this step. Don't just do it in your head, because that's where I see most students have issues. So that derivative is going to be 5 times 2 is 10, so 10x to the 4th, look at my parenthesis too, plus 7. All right, let's write this the way you would most likely see it in a textbook. So f prime of x equals, so I have a 1, so just follow what I'm doing. Then I have 1 times 10x to the 4th plus 7. So I don't really need that 1, so I'm going to make that my 10x to the 4th plus 7, and then in the denominator goes the 2 from the 1/2, and now I really could return to my radical notation, and I have 2x to the 5th plus 7x under the radical. And that is absolutely how you would see that answer in a textbook if you're checking answers in the back. All right, so look over that and make sure that makes sense. This is the chain rule, and it's a very powerful rule for us, and it comes up all the time. So you have to remember that if you are taking the derivative using the power rule, and your x is not just a plain old x, but instead a function, you've got to take the derivative of what's inside the parentheses. Okay, let's go to the rest of the notes, and then we'll talk about the homework. On the bottom of the notes page, there's a little paragraph about the derivative as a rate of change. And we've already stressed that, but because they mention it again in this section, I thought I would type it up here for you. So remember two important properties of a tangent line to a graph at some point A. So remember that when you find a derivative, you are finding the generic slope of any line drawn to that particular function. The generic slope is f prime of x. Your specific slope, that is the slope of the function drawn at a certain x value, and let's call that x value a, will be f prime of a. So if I ask you to give me the equation of a tangent line, so for example, if I say, okay, give me the equation of the tangent line drawn to some function at some value x1. Okay, the m right here is not just the formula for the slope, it's the actual slope. So we're going to erase the m, and we're going to instead put in your slope. So I would say f prime of not just x, but f prime of x1. So remember to differentiate between the generalized slope and the specific slope when writing an equation of a tangent line drawn to a curve. The next thing is you should be able to recognize some terms as interchangeable. You can call something f prime of x. You can call it the rate of change. So the slope is the rate of change at a certain point. So keep that in mind. Okay, the last thing I want to talk about is the homework for this section. So you're going to do 1 to 37 odd. I believe you start using the chain rule at about problem number 9. I have little stars next to these problem numbers, and that is because there are matching videos for those problem numbers, and those videos are under the resources for 1.6. In addition to those 3 videos, I would like you to look at these videos listed right here, because they are important reviews of this particular section. So good luck. That's the homework. That's the little review. So, practice using your chain rule. Practice thinking of circumstances that require you to use it, and that will help you to be successful.